Welcome to our class Form 4 work, Uniform Circular Motion. So today we want to start with terms, definition of terms. The first term is angular displacement. So the definition for this one here, it is the angle. This is the angle in radians, through which a point has been rotated in a circular path. That's the definition. So if we draw a circle, and we include this angle here, this angle is what we call angular displacement, as long as it's a point or a line that has been rotated through a specific path. It means this angle now, it's what we call angular displacement. SI unit of angular displacement, SI unit is in radians. SI unit is a radian. Then now the formula theta equals to S, this is the distance, over R. That's the formula of angular displacement, S over R. We want to move on. We want to define the term a radian. What's the meaning of the term a radian? So radian now, also a radian is an angle where it's the angle where the angle in degrees, it's the angle where this S is equivalent to R. When S is equivalent to R, then we talk of radian. It's the angle, that's angle when S is equivalent to R. So we have conversions. How can we convert from radians to degrees? This is what we use. Pi equals to 180 degrees. This is what we use. This is the formula that we use to convert from radians to degrees. We want to move on. So we want to move on to another definition. Another definition now, the second definition is what we call angular velocity. Angular velocity is the second definition. Angular velocity. Angular velocity, it is omega. We use that symbol omega. We want to define this one here as the rate of change. Rate of change of angular displacement. Angular displacement. The rate of change of angular displacement. The word rate in our case here means time. Rate means time. So we can come up with a formula. The formula for angular velocity omega equals to theta over time. That's the formula for angular velocity, whereby we said where theta is angular displacement and t is time. So remember we said the SI unit of angular displacement is in radian. and the SI unit of time is in seconds. So now, what is the SI unit? SI unit of angular velocity. SI unit of angular velocity. SI unit of angular velocity will be radian per second. That's the SI unit of angular velocity. Then, so this is the formula of finding angular velocity. We have other formulas of finding also angular velocity. We can write those formulas like this one here. This is formula: angular velocity equals to V over R, where V is linear velocity, R, it is the radius of the circular path. So if we cross multiply this formula here, we can make V the subject. We cross multiply and make V the subject of the formula. Now V equals to omega R. So those are the formulas where V is the linear velocity and omega is angular velocity and R is the radius of the circular path. So we want to move on to the third definition. The third definition is a period. That's definition number 3. Period, we use capital T. We want to define period. This is the time taken for a body to move in one oscillation. So we write is the time taken for a body to move in one oscillation stroke cycle. And now we can give SI unit of period. The SI unit of period, remember that's time. We talked about time, and we know SI unit of time is the SI unit is second. That's the SI unit of period. So we have this formula here that we have already learned in form 2, that period T from waves 1, T equals to 1 over F. This formula will help us in this uniform circular motion to work out some questions. So make sure you remember that formula, and also this formula, and you have this formula. They are very, very important, and also this conversion. Then we want to work out some questions here. One example in a question. So this is the question. We want to write this question down. An application of our formulas. We want to work out a question on the application of our formulas. The question is, this is an example. The question is, that's question number 1. Number 1 is a turntable rotates at a rate of 45 revolutions per minute. What is its angular velocity in radian per second? Look at that question. Let us try to work out that question. Write solution. So this is the question. A turntable rotates at a rate of 45 revolutions per minute. They have given you the frequency. The frequency has been given in terms of revolutions per minute, but you have to change this frequency to revolutions per second. So what is its angular velocity in radians? So what you know here is you have to remember our formulas that we have learned. So we have learned this formula here before. Angular velocity equals to 2 pi over t. That formula is very important. So now your work now is to substitute the value of t, that is time. You must find t. So where t can be found from our formula 1 over f, which equals to 1 over, then convert, it should be 45 over 60. So then now use your calculators. Yes, use your calc. I have my calculator here. Can use it. Also use yours there. And we compare the answers. It is 1 divided by 45 over 60. You get your answer in improper fraction as 4 over 3 seconds. So that is the t. So now in our equation, we can find the angular velocity, which is 2. Let's take our pi to be 3.142 times 3.142 over time. The time is 4 over 3. Then now use your calc again. 2. Yes. So omega equals to this substitution, 2 times 3.142 over 4 over 3. So from use your calculators well there. 2 times 3.142, you close the bracket, divided by 4 over 3, and you get your answer, and your answer is giving out here 4.713 units. Units must be written. So that's our answer. So look at our working here. We have written the formula omega equals to pi over t, and t is time in seconds. It is time in seconds. So t, you have to find the time in seconds so that you can substitute. But our formula for t, it's 1 over f. We had 45 revolutions per minute. You have to convert this 45 revolutions per minute to seconds, to revolutions per second. So that's why we have written 45 over 60 down here, so that you're able to convert to seconds, so that it is now into seconds. This time here. So you have to convert. To revolutions per second. So the time should be in seconds. So then now use your formula. Use your formula and find t. You find t. So this frequency must be in revolutions per second. So that's our working. So we have to stop there. Till our next lesson. My name is Amayo Vincent from Kiamutugu Boys. Thank you for listening to me.